Okay, let's take a quick look at vector and scalars. So I've already drawn a couple of things on this page. Basically everything on the left hand side will be relating to vectors and everything on the right relating to scalars. We're going to start with vectors. Now a vector is any measurement that has both direction and magnitude. Okay, a simpler word for magnitude is size, but we'll also write magnitude in brackets next to it, so magnitude. Okay, so we can represent a vector with a simple arrow. Now, the arrow obviously shows the direction in which direction it's pointing to, but it also shows the size in its length. So the length of the arrow is actually representing the size or the magnitude of that measurement. So we'll put here length shows size or magnitude again. Okay, it is important to start using this word magnitude. I'm simplifying it to the word size, but do use magnitude. Okay, now some examples of vectors, measurements that have both a size and magnitude. Probably the most common, or at least one of the ones you'll be using most early on, is force. Now a force of say 5 newtons has both a magnitude, so a size which is 5 newtons, but also a direction to it. So the force could be acting upwards, as shown in this arrow here, or it could be acting horizontally, as shown in this arrow here. And we can show multiple forces acting on one object simply by pinning different vector arrows to that object. A couple of other examples of vectors would be velocity. Velocity has both a size and a direction. Also acceleration is another common one. Acceleration, some less common ones would be, certainly one that you'll be coming across though, is momentum. And see if I can think of any more. Magnetic field strength. Has a direction as well as a force. Okay, scalars are a little bit simpler. They're basically things that have a, if I change my ink color back, they will have a magnitude. Okay, so size, magnitude, but no direction. So when you hear the word scalar, you probably think of a scale, and that's a good way of thinking of scalar measurements. They have a size, they have a physical size to them, but the direction really doesn't matter. Some examples of scalar measurements are things like mass. For example, something will have a mass of so many kilograms, but those kilograms aren't acting in a particular direction. We've also got time. So seconds will be passing, but not in a certain direction. You can't have vertical seconds. Another example is temperature. Okay. If you're measuring Kelvin, of course, temperature can be in the positive or negative according to its scale, but it can't be acting within a direction. So there are 3 basic examples of scalars, and this has just been a quick video on vector and scalar diagrams.